Temperature measures the intensity of heat, essentially the hotness or coldness of a body. There are three temperature scales: Celsius, Fahrenheit, and Kelvin. Celsius is the metric scale, Kelvin is the SI scale, and Fahrenheit is the one we use commonly here in the US. I've given you the boiling point and freezing points of water on these three temperature scales, and what you'll notice is on the Celsius scale there's 100 degrees difference between the boiling and freezing, and on the Kelvin scale there's 100 degree difference between the boiling and freezing. On the Fahrenheit, however, there's 180 degrees between the boiling and freezing. So when we compare the Celsius to Fahrenheit, we can set that 100 degree difference equal to the 180 on the Fahrenheit, and we can get conversion factors, 5/9 and 9/5. But the starting points on the Celsius and Fahrenheit are also different, and that leads us to our equations that allow us to go from Celsius to Fahrenheit and vice versa. Now, if you need to use these two equations here, I will give those to you on the test, so you don't have to worry about memorizing these equations. Look at the problem. What Celsius temperature corresponds to 98.6 degrees Fahrenheit? Well, if I'm solving for Celsius, I'm going to use that first one. And I'm simply going to plug in the 98.6. We're going to subtract the 32. We're going to multiply by that conversion factor 5/9. And we're going to do the subtraction first before we multiply by 5/9. But when you do the subtraction, you multiply, you will get a value of 37.0 degrees Celsius. Now, the conversions between Kelvin and Celsius are actually even easier than Celsius to Fahrenheit. If I want to go from Celsius to Kelvin, I simply have to add 273. So this is a lot easier than going from Celsius to Fahrenheit. We're going to use the dimensional analysis approach when we solve problems. A measured quantity has to be accompanied by a unit, and that unit indicates the standard against which the measured quantity is to be compared. So for example, a metal rod that's 9 meters is 9 times as long as a standard meter. That makes sense. A number of calculations that we use are going to require a conversion of measured quantities from one set to another. Let's consider this equality. 1 inch equals 2.54 centimeters. From this equality, we can get what's known as conversion factors. So let's say 1 inch equals 2.54 centimeters. We can divide both sides by 1 inch. And we can simplify that. 1 inch over 1 inch is 1. And that would give me 2.54 centimeters over 1 inch. Now when I multiply by 1, I don't change the actual quantity. And since 1 is equal to 2.54 centimeters over an inch, that's my conversion factor. I can also take that equality and divide both sides now by the 2.54 centimeters and give me another conversion factor. And this will simplify to 1 inch over 2.54 centimeters equals 1. But these two things are called conversion factors. They allow me to go from one unit to another unit in a problem. So let's look at a couple examples here. First one, what is the length of 22 inches expressed in centimeters? Well, I'm going to start with 22 inches. And I'm going to put that over 1 to show that the inches is in the numerator. I want to cancel units, so inches has to go on the bottom now, and I can go directly from inches to centimeters. We just had those numbers, 2.54 centimeters and an inch. The inches will cancel, and I'll be left with centimeters. Now when you're doing conversion problems, pay attention to significant figures. We're multiplying. 22 has 2 sig figs. 2.54, that's an unlimited number of sig figs because that's a defined quantity, an exact number. So my answer can only have 2 sig figs. So it comes out to 55.88, but I need to round that to 56 in order to get 2 significant figures. Next example. How many feet squared correspond to an area of 1 square meter? I'm going to start off with 1.00 meters squared. I've given you the appropriate conversions. I need to go from meters to inches because that's what I'm given in the problem. Well, there's 39.37 inches per 1 meter. That's only going to cancel 1 meter. It doesn't cancel meter squared. What I need to do is rewrite that equality one more time. Because meter times meter will cancel with meter squared. So that will cancel those units. Now I have inches. I want to go to feet. Well, there are 12 inches in a foot. But I'm going to have to write that equality twice so that the inches will cancel out. And the units I'm left with are feet times feet, which is feet squared. Sig figs. 1.00 has 3 sig figs. The rest of these are exact quantities because they are defined for me. So they are an unlimited number of sig figs. Multiply by everything on top, divide by everything on bottom. My answer can only have, though, 3 significant figures. So the 3 sig figs is going to round to 10.8 feet squared. 10.8 feet squared. One more here. What is the volume occupied by 50 kilograms of ethanol? I'm going to start with the 50 kilograms. I'm going to put it over 1. The temperature does not matter in the problem. It's not going to enter the equation, but I'm starting with kilograms. My density is in grams, so here's what I need to do. Convert kilograms back to grams. In 1 kilogram, that's a prefix, there are 1,000 grams. That will get rid of kilograms. Once I get to grams, I can use the density as a conversion factor, 0.789 grams in 1 cubic centimeter. That will get rid of grams. I want it in liters. Well, a cubic centimeter is the same thing as 1 milliliter. That's defined. And milli is a prefix. It means 10 to the negative third liters. And so that will get me to the liters. Sig figs, 50.0, that's 3. Kilo is a prefix, that's unlimited. 0.789, that is a measurement. That also has 3, though. 1 mil, 1 centimeter cube, that's unlimited. And liters to milliliters, that's unlimited as well. So my answer has to have 3 significant digits. So again, multiply by everything on top, divide by everything on bottom, and you will get the volume in liters.